So building up on the things we discussed in the previous video, we looked there at the effect of multiplying numbers of the same bases with certain powers. And today, we're going to do something relatively similar, but we're going to start looking at the effect of dividing these. And we're going to use that to establish a general rule or law for the division of these types of indices. So I'm going to start with some really kind of small numbers just to show you how this works, things that you can kind of just do in your head. And we're going to establish this rule for dividing indices. So let's say I gave you, let's say we wanted to do this. So 2 cubed divided by 2 squared. Okay. Now, as we said before, this is just like writing 2 times 2 times 2. This is like writing 2 times 2. So 2 multiplied by 2 gives us 4. Multiplied by another 2 gives us 8. So we have 8 here divided by 4. Okay. Obviously, this isn't too crazy of a division. We will just get this equaling to 2. Now, all right, well, this is kind of the actual procedure we did. It wasn't that bad, but let's look at what has actually happened with our powers here. Well, we ended up with essentially just 2, which can also be written as 2 to the power of 1. Now, how did we make, or how can we make 1 out of these two numbers? Well, I don't know about you guys, but to me it looks like we can subtract 2 from 3. Okay, this is just one example. Maybe this isn't true for everything. Let's try a couple more. So this is example 1. Now don't take my word for it just yet. This is just something that I've observed. And hopefully you can see what I mean in terms of this example, but let's look at one more. Two more. Let's do 2 more. Well, what if I were to take let's divide, okay, let's say 3 cubed divided by 3. All right, well, 3 cubed, this is like saying, well, 3 times 3 times 3, and we just have a 3 here. So that's all good for the time being. But 3 multiplying by 3, we get 9. And then 9 multiplying by 3, we get 27. Okay, well, let's find, in essence, what we're asking here is we're pretty much finding, once we do the actual arithmetic on 3 cubed, we get 27. Let's do it in this color. We get 27 divided by 3. And we know that this gives us 9. But how can we write 9 as some base with some power? Well, this can just be rewritten as 3 squared, right? Because 3 times 3 gives us 9. So these two are pretty much equivalent statements. They mean the same thing. I can write this either just as an integer or some base number to some power. But another curious case that arises, well, to get 2, we could have just done 3 minus the 1 here. When we have just 3, that's like saying 3 to the power of 1. So it's kind of curious. The same thing happened as before. To get 2 in this answer, we just did in the powers 3 minus 2. And here we did 3 minus 1 to give us 2. And this one up here gave us 1. So, okay, one more. Let's do one more example. And then that should be enough to construct sort of a general formula for these divisions of indices. Now, all right, let's pick, okay. Let's pick 2 to the power of 4 divided by 2 to the power of 2. Okay, so 2 to the power of 4 is like writing 2 times 2 times 2 times 2. Now, 2 cubed was 8. 2 times 2 gave us 4, times another 2 gave us 8. Timesing that by another 2 would give us 2 to the power of 4. So this is like writing 16 divided by 2 squared. It's like saying 2 times 2, which is 4. And when I actually do this division, what do I get? I get 4. But 4 is the same as 2 squared. But look at that. That's if I put it in the same base as these two numbers, what I've effectively done is just subtracted 2 from 4 again. So this, I mean, we could have gone through this whole thing, but we also could have just gone, because this follows all the same patterns that we've had before, that's like saying 2 to the power of 4 minus 2, which gives us this as well. So indices are just a different way, a shorthand way of working with numbers when we multiply these same numbers. And these same these same bases here. We established in the last video, as well as this video, that when we multiply and divide numbers of the same base to some power, some patterns start emerging. Now, hopefully you can all see the pattern here. But if it's not immediately obvious, I'm going to come up with a general formula here. Now let's maybe go here. From all of these we saw, we can construct a general formula for dividing indices. Okay. And that is that when we get any two numbers, I've just drawn these as A, to some power m divided by our same base to the power of n is the same effect as subtracting the number that's being divided, taking the number that's being divided, and we are subtracting the power of the one that's getting divided by. So we can write a general formula here as a to the power of m, any two numbers, these can be any numbers, divided by the same base to some other power, is the effect of taking that same base and subtracting the powers. And this is our general formula for dividing indices. We'll do one more in the next video, and then we're going to start working through some examples. I'll see you guys there.